Hi kids, so as promised, I'm gonna make you a little video about my thought process around angle chasing and justification. So I'm just gonna walk you through it. I'm gonna fill this in as I go. I'm gonna get as far as I can in the little bit of time that I have. And hopefully this helps you understand angle chasing a little bit better. Okay, so what we've been given is this picture. And we have a couple little other givens over here to the side. We know that NO is an angle bisector, which means that it cuts angle WNF into two equal parts. So let's talk about what that means. NO, this line right here, cuts this angle WNF into two equal parts. So as an example, if this was 10 degrees, the other side would be 10 degrees because it cut it into equal parts. But we don't know that, so I'm gonna erase the 10. Okay, the other thing we know is that measurement of angle HRK is 114 degrees. I've already filled that in. And the measurement of FNM is 68 degrees. FNM, and I filled that one in too. Okay. So now if you're checking my work that I've given to you already, we always write our given information first, and the reason that it's true is that somebody handed it to us. It was given. Now, I think I've said this to you in class multiple times, but my favorite types of angles are vertical angles, those kissing angles. So that's kind of why I went with angle WNT right here. I said that it was 68 degrees because when I was over here, I noticed vertical angles, okay? So if FNM is 68 degrees, its vertical partner, WNT, is also 68 degrees because they are vertical and vertical angles are congruent. Okay? And so then from there, I went and I found angle RTE. I know angle RTE because it is corresponding with my given angle. Corresponding angles, of course, are congruent when lines are parallel. So that's where this reason came from. So now I'm going to do a few more, and hopefully it makes sense. Let me go back to my picture and see what I got going on. Now, like I told you, I love vertical angles. They're easy to find for me, okay? So maybe I'm up here. I see that 114 is kissing this angle right here. And automatically I know that that inside angle is 114 degrees. The way I would name this angle, obviously R has to be in the center of the name, and then I just choose a letter from this side, which I would choose W, and a letter from this side, I would choose T. So I can name it WRT or TRW. So I'm gonna go ahead and write this. I'll go TRW. The measure, oh wait, I won't write that because I don't have enough room. TRW equals 114 degrees. Now the reason here is angle TRW and that original angle that I was working off of, angle KRH, are vertical angles. And vertical angles are congruent. Yay. So now I'm going to go up here. Oop, I see more vertical angles. This angle here is kissing this one right here. And I'm all set. I can call that 114. The name of this angle is DTN. So here I go. Angle DTN equals 114. And that's because I'm going to write a very similar response as I did before. DTN. And angle ETR are vertical angles. Vertical angles are congruent. okay? I think it's a great place to start by filling in all your verticals. I think they're the easiest. So now I'm gonna come back over here, and I don't see any more vertical angles. So what I might move on to is what's called linear pairs. I like linear pairs because I can put my pencil down on a line. If I see an angle on one side of a line, I can find the other side of it because these two angles are called a linear pair. They make a line. Now the way I find the angle measurement of a linear pair, every single time I do 180 minus the angle that was given. So 112. Yay. So, oh, the measurement of that angle is 112, and the name of it is TNM. So here we go. TNM equals 112. And the reason for that is TNM are a linear pair. Wait, TNM, gosh, good thing I write in pencil. TNM and WNT. Notice that every time I state the relationship and then what the relationship means. Linear pairs are supplementary. I'm going to run out of room, so I just ran. Okay. Now here's where things get tricky. We actually have two separate angles here. But for a second, pretend that this line wasn't there. Do you see a vertical angle to 112? Hopefully you do. Angle WNF, where my pencil eraser is pointing at, is a vertical angle to the 112 I just found. So the whole angle is 112 degrees. But remember, this was that angle that was split into two equal halves. So I could take 112. It's hard to hold the phone and write at the same time. Here we go. That goes in there 5 times. So when I cut 112 into half, I got 56. So that means this angle is 56. And this angle is 56. Okay, so now let's talk about how we got there. I'm gonna start with angle WNF. Angle WNF equals 112 degrees. And the reason for it, I hope that you're catching on, is that it's a vertical angle. Angle WNF and TNM are vertical angles. Vertical angles are congruent. I abbreviated because I'm getting lazy now. And now we can say this, WNO and equals 56. And not W, FNO equals 56. Now this reason's a little bit fancy, so I'm gonna give this one to you. If you didn't understand how to do it, no problemo. I'm gonna write my reason here is because NO is an angle bisector. So I first had to find the big angle, then I found the measurements of the small angles because of the angle bisector. Okay, so I'm gonna keep going now. So I might kind of focus on this parallel line and this parallel line cut by, oh, I don't know, let's say this transversal. So if I'm really focused on those lines and that transversal, I notice that this 56 degrees is an interior angle. Now, if it's interior, then I can find its partner called an alternate interior. And an alternate interior is going to be still on the inside of the parallel lines, but on the opposite side of the transversal and up here. So this angle up here is 56 degrees, and this is called angle WON. Angle WON is 56 degrees. And the reason is WON and O and F are alt int. Alt int are congruent only when the lines are parallel. Cool. Let's keep going. I might find now this angle, because it has a relationship with this one, that relationship is a linear pair. So remember, to find a linear pair, I just find any space and do 180 minus the given angle. So this angle is 124. Okay, here I go. Angle GON. And the reason because is GON and WON are a linear pair. Linear pairs are supplementary. Okay, so now I'm halfway done. It's taken me about 12 minutes. Of course, I've done this before, so if it seems like I'm making it look easy, it's because I'm old and I've been doing it a while. Okay, this is tough. It's a good challenge. But so far, now we have a lot of examples. In the reason section, you're pretty much 99% of the time going to write the two angles that have a relationship and what the relationship is. Then you state what that relationship tells you. Corresponding angles are congruent when lines are parallel, or vertical angles are congruent, or linear pairs are supplementary. You tell me what the importance of that relationship is. And now, if you want to check your angles to see if you got them all right, that's the answer key. Okay, kids? So try it on your own. Come to tutoring. If you need me, I got you. Okay? Good luck. You're wonderful. Bye-bye.